Hey guys, this morning we're going to be talking about 4.2, which is a standard form of a quadratic function. And so I want to start by talking about vertex form, and then we'll talk about why we need standard form and kind of what the differences are, kind of how it's developed. And then I'm going to work through just a couple of problems with you as well. You only have 6 problems today, so it's going to be a pretty easy day for you, I think, but we need to set up a little groundwork. So first of all, let's talk about vertex form. So remember that f of x equals plus or minus a x minus h squared plus k. This is vertex form. And so, again, I could exchange this f of x with y. It doesn't really matter what that is. They both mean the same thing, function of x or y. But again, all these parts hold a significance, remember, in vertex form. And so we won't go through all of those because you spent a couple of days already kind of looking at those. But again, one of the most critical things is the reason vertex form is so appealing is because you can see the vertex right here clearly, okay? There's two main reasons that this is a good form, okay? So remember, your vertex is h and k, so it can clearly be seen right here in this form. Also, the other thing that's really cool about vertex form is that you can see all the transformations that are really happening, okay? Unfortunately, the drawback to standard form is the fact that when it comes to solving these equations, which is where we're headed next, it's really a lot easier to do in the standard form of a quadratic function, okay? So what I want to do is I want to go ahead and write out standard form, and we'll kind of look at some similarities. I don't think I'll go through the whole proof just because I don't want to keep this video like 30 minutes long, but so standard form, this again was vertex form. Standard form is f of x equals ax squared plus bx plus c, okay? Now, one of the things you're going to notice right off the bat is you're going to notice this a right here, okay? And you'll notice it's in exactly the same position as that a there. So actually the a in standard form is the same. It basically talks about whether we have a shrink or a stretch or compress. Also, it's not really noted here, but again, positive or negative would indicate whether I had a reflection. So that part would also kind of be the same. The problem is, where's the vertex? Okay, there's no h, there's no k, there's none of that that's here, okay? So with standard form, the vertex is actually hidden, which is kind of a problem, but it's not a problem that we can't solve, okay? So actually, believe it or not, this is derived from this, okay? And again, we could go through a 15-minute proof to kind of show you how that's done, but I don't want to really take the time to do that. And so instead, I'm just going to go ahead and give you the formula that will help you to understand how to find the vertex, okay? So the vertex, again, is hidden in here, and you actually use some of these letters that are in here in order to be able to find that, okay? I'm jumping ahead just a little bit because one of the other things that we talked about was we talked about an axis of symmetry. And you'll remember the axis of symmetry. Let's just draw us a little sketch here real quick. So if I had a graph that kind of looked like that, and my axis of symmetry would be that imaginary line that kind of goes through the middle. And if I were to rotate this quadratic function, then they would land in exactly the same spots. And remember this axis of symmetry, again, AOS, we said is really just your x coordinate, okay? So actually, what I'm going to show you how to do is how to find out what the x coordinate or even the h coordinate of your vertex is, and then we're going to use that to try to find everything else, okay? So in order to find this x coordinate of your axis of symmetry, you're going to take negative b over 2a, okay? And again, I could go into a big long proof about why that is the case, but for the sake of time and energy, we're just gonna you're gonna have to trust me. All right, trust me that this is how we find the x coordinate in our vertex when we're given standard form like this right here. Okay, so what I'm going to do, I'm going to go ahead and erase this part of the screen, and I'm going to put us up a problem here, and we're going to do the same thing we did with vertex form. We're going to find the vertex, the axis of symmetry, whether it has a maximum or minimum, and find the range. Okay, so let me really quickly just erase everything here. I want to leave our title so that we see that. Okay. Almost done. All right. So now again, let's write down our standard form. F of x equals ax squared plus bx plus c. All right. So if we had a problem that looked like this, we'll just call this number 1 for the sake of keeping up with it. Let's say we have y equals negative x squared plus 2x minus 5. Okay. And we're asked to find the vertex, the axis of symmetry, the maximum or minimum, and the range. Okay. So really quickly, we can tell again, remember these two things here are still the same as they were in vertex form. So by seeing this negative, what does that tell you? I want you to just think about that for just a second. What does that say about this graph? Well, one of the things it should tell us about this graph without actually graphing it is that we know that this graph is going to be turned down, okay, like so. Now, don't quote me on this vertex yet. We still got to find that, okay? I'm just simply pointing out that the fact that this has a negative right here tells me that this graph is going to be pointing down, okay? That's going to come into play here in just a few minutes. So remember that our equation, our formula to find the vertex when we're given standard form is x equals negative b over 2a. And this is going to become more and more familiar to you as we get into later subjects. You're going to be able to do this pretty quickly. So let's look really quick at what is in our b position. Notice this is written out exactly like my form, right? So notice that where b is here, we have a 2 here. So what I'm going to do is I'm just going to put in a negative 2 right there, okay? Again, the negative is kind of always there in the formula, and the 2 I just derived from right here as b, okay? Over 2 times a, and what is a? Well, a here, I don't see it, but I know that there is a 1 right there. So that is actually negative 1. So really what I have is negative 2 divided by negative 2. Well, a negative divided by negative is a positive, so that goes away. 2 divided by 2 is going to equal 1. So what that told me right then was that my vertex, and I'm going to go ahead and start writing this over here. My vertex, my x coordinate is 1, okay? I know that much already. Now, I need to figure out what the y coordinate will be. Well, notice our equation here. We started with y equals, which is the same as f of x equals, right? So actually, I can just substitute in this value for x right back into my original equation, okay? So I end up with y equals negative 1 squared. Notice I'm putting that 1 in parentheses so that I can kind of keep up with what's going on. Plus 2 times 1 minus 5, okay? So let's think about this carefully. I have 1 squared, which is 1, but remember there's a negative out in the front of this. So that means that actually is a negative 1 plus 2 times 1, which is 2, minus 5. Okay, so what do I end up with? I end up with negative 1 plus 2 equals 1. 1 minus 5 is negative 4. So this is my y coordinate in my vertex. So there's my vertex. And remember, once I have the vertex, really I have everything I need in order to be able to solve everything else. So think about what your axis of symmetry is. Your axis of symmetry, again, is your x coordinate. So my x coordinate was a 1, so my axis of symmetry will be x equals 1, okay? Now let's think about whether this has a maximum or minimum, and this kind of goes back to this little drawing that we started with right over here. Remember we said because this is a negative, it's going to be turned downhill, which means what? Does it have a top or does it have a bottom? Well, keep in mind this goes down forever in the negative direction, but it does in fact have a top right here. So it does have a maximum. And you might say, well, where is that maximum at? Well, remember your maximum is always your y coordinate. So it's actually negative 4. So it has a maximum at y equals negative 4. Okay. One last part here we need to do, and I'm going to erase my number just so we got that out of the way. And one last thing we need to do is we need to do our range. Okay, so our range, think about this, it's going to be going down to negative infinity. So I'm going to write negative infinity first because that's how far it goes down. And how far does it come up before it stops? Well, it comes up to -4. So again, our min or our max plays into that range as well. Okay, and I made a mistake here. I'm going to go ahead and fix it real quick. Remember, if it includes that -4, that we need a bracket there. Okay, so this would be your answer, in fact, for that particular problem that we were looking at. Again, a little bit of work there, but I think you can figure out that we can do this without any problems. Now, one thing you could also do is we could also graph this so that you could, in fact, see it graphically as well. I apologize, this thing does this. I'm not sure why it does it, but it does. So we had negative x squared, right? We had negative x squared plus, just do it this way. If it's going to be this ornery to us, we're just going to do it. Plus 2x minus, that's not a minus, minus 5. Okay. Now let's look and see if we can find our graph. And notice there's our graph. Again, we were just drawing a rough sketch there a minute ago, so it doesn't look exactly like this. But what I want you to notice is this. If I go here and I point to where the vertex is, look at that, +1, -4. So it does add up with what we did algebraically. So again, you can kind of see some of this graphically as well. I know that's probably the way you're going to do it, but I want you to be able to do it manually as well, because there's going to be times you're not going to have a graphing calculator, and I want you to be able to do this work as well. Okay, so let's look at one more example before we quit for today. In this example, you're to convert something that is written in standard form into vertex form. Okay, so I'm going to go ahead and I'm going to erase the whole page this time. All right. And so this particular problem we're given, we'll call it number 2. And we're given y equals 4x squared plus 16x plus 19. Again, to get this in vertex form, well, obviously, I'm going to have to find the vertex. So one more time, the way we find the vertex is the x-coordinate of the vertex anyway, is -b over 2a. Okay? So remember our form, standard form, f of x equals ax squared plus bx plus c. So I'm looking for -b. So negative and b happens to be 16 over 2 times my a term, which happens to be 4. So I end up with -16 over 8, which happens to be -2. Okay? So what that has told me is at least part of my vertex, I know at this point, my a coordinate of my vertex is -2. Okay? So now let's how do we figure out the y coordinate? Well, again, we just plug in -2 for everywhere we have an x. So I have y equals 4 times -2 squared. Notice I'm putting that inside parentheses, plus 16 times -2 plus 19. Okay? So let's work out some math. -2 squared, be careful, again, this is inside parentheses, so -2 times -2 is actually +4, okay? +4 times 4 would be 16, plus 16 times -2 would be a -32, plus 19, okay? So we're on the home stretch. Y equals 16 plus a -32, that's going to be -16. -16 plus 19 is actually going to be a +3. So my y coordinate in my vertex is a +3. Now, there's a couple of different things we can do here. We're trying to get this to vertex form. So let's write that form real quick. Vertex form is plus or minus a x minus h squared plus k. So let's fill in what we know here. Well, if you look here, remember this is h and this is k. So that means I could literally take this -2 and I could put it right here. But what I want you to remember is this negative is part of my formula, okay? So y equals, we'll skip this part for now, we'll come back to it. X, if I had minus a -2, minus a -2 is actually going to become a +2, okay? So I just wanted you to see that. I'm going to erase that out real quick. We'll write that over. So it's going to be x plus 2 squared. And I'm just getting this from this vertex that we just found out, okay? Again, if you know the vertex, you pretty well can figure out everything else. All right, now k is 3. So remember that's a literal, so just +3. Now you might be thinking, well, what about this a here? Well, remember the a in vertex form here is exactly like the a here in standard form. So I've already got my value for a right here, which is 4. So guess what? I put my 4 right there. And ladies and gentlemen, I'm done, okay? So let's do this just for fun, just to see if it works out, is we're going to go ahead and stick this guy in the graphing calculator and see if we come up with the same graph that we get for that one right there. All right, so let's try that real quick. And we're going to clear that one out, and we're going to do a new one. And of course, it's going to pop up that little screen, but we don't care because we're going to make it work anyway. Y equals, and again, we had 4 parenthesis, we had x plus 2, and that was squared. And then we had plus 3. So let's take a look at that. See if we can find the graph, and there it is. Okay, now let's do this same thing. Now we're going to use our standard form again that we originally started with. So y equals 4x squared plus 16, 16 x plus 3. We're on the home stretch. Plus 19, I'm sorry. And notice what happened. It absolutely covered up that other graph, okay? Which means that those two things, these two things right here, are actually equivalent statements, okay? So we did our work right. Again, hopefully, there wasn't a whole lot of confusion with this, but again, the main key is if you need to find the vertex given standard form, you're going to take -b over 2a, and then remember this is your standard form right here, okay? So as long as your equation looks like that right there, you can be able to use a and b and c to be able to figure some things out, okay? Hopefully this has been helpful. If you have any issues, please contact me or Miss Wheeler, and we will be glad to try to help you out with this, okay? Thanks.